Alright, welcome to another video by Johnny, Dr. John IELTS. Science. I have so many channels, so I'm confused with the introduction sometimes. So here we are, we have a one-on-one lesson in chemistry, and we are working on building and naming compounds in organic chemistry and inorganic chemistry. Just general. Now, so Mr. An is going to work on it. Now, so can you continue? There are two types of ions, anions and cations.
Ions. When an atom gains electron, it gains negative charge. Since the number of proton has not charged.
Change. This is changed.
Oh, sorry, changed.
Careful. Since the number of proton has not changed, the charge in the nucleus remains the same. Be careful. Charge and change are different words,
The charge in the nucleus remain the same. So the atom has an overall negative charge. A negatively charged ion is called an anion. Non-metals such as halogen tends to gain electron and form anions. Remember that the halogen have 7 electrons in their valence shell, and atoms needs 8 to become stable. This process can be shown using a Rutherford diagram. This anion forms when the chlorine atom gains 1 electron, highlight in the red, right here, and so has charge of 1 negative and is stable. In Bohr-Rutherford diagram, ions are shown in square brackets with
the charge shown outside the top right corner of the bracket.
Corner of the bracket.
I always thought that this kind of bracket thing is just silly. But well, maybe it's meant to be, because if you show a charge, positive, negative, outside, people will be like, what is that? So you need a bracket to make people, to signify people that this is an ion. Even though it seems a bit silly to me, I think. Alright. Continue, please.
Chemists use
specific notation
to show the type of ion that forms. A superscript number is used to indicate the number of electrons transferred, unless the number is 1. Anions are shown with a bracket. In this case, chlorine would be
Chlorine would be denoted as Cl minus.
Chlorine would be denoted as Cl bracket. Okay. Cation, is that what's it called? When an atom loses electrons,
when an atom loses electrons, it loses negative charges.
Since the number of protons has not changed, the charge in the nucleus remains the same. So the atom now has an overall positive charge. A positively charged ion is called
a cation, not cation, okay? Not cation, it's cation. I was like, when I was learning it back then, I was like, cation? No, it's cation. Cation.
Cation.
Cation.
Cat.
Cation.
Cat. Ion.
Alright. Now, so, basically, whatever changes is just about the electron outside, isn't it?
Yeah.
So basically, if you loses an electron, you loses something negative, isn't it? So when you loses something negative, you actually become more positive. That's the thing.
Yes.
And in the opposite case, when you gain an electron, you gain more negativity. So basically, that ion become even more negative. All right, that's what it means. Okay, let's continue.
Metal tends to lose electron and form cation. Metal tend to have one or two electrons in their valence shell, so they are willing to give them away to get rid of this outer energy cell and become stable. The cation formation process is shown in the fourth diagram. The ion form of the atom is shown inside square bracket, with the ion charge in the upper right corner. A superscript number is used to indicate the number of electron transfer, and a plus is used to indicate the overall charge on the ion.
Mhm.
Sodium cation Na1 plus is usually written Na plus. The sodium atom with 3 electrons shell loses 1 electron. Since there was only 1 electron in its valence or outer shell, that valence shell disappears and the ion now has 2 shells. Its new valence shell is full with 8 electrons. The ion has a charge of 1 plus and is stable. Chemists use specific notation to show the type of ion that forms. A superscript number is used to indicate the number of electron transfer unless the number is 1. Cations are known with a plus. In this case, sodium would be noted as Na plus. Self-check. Magnesium chloride is another example of an ionic compound. Use the following diagram to answer the question. Have your periodic table at hand.
So of course, positive ions, because they lose this electron before, because they lost electron before. So that's why positive ions is a bit smaller than negative ion.
Yeah.
I mean, but not all the time. Okay, it depends on what they start with. They just loses. Okay, basically positive ions, they lost some electrons, so they become smaller, and negative ions, because they gained one or two electrons more, so that's why they just get bigger. But it doesn't always mean that negative ions has to be bigger than positive ion. It depends on what you start with. You know what I mean?
Yeah.
Are you sure? Like, for
Yeah.
example, if you start with a very big atom, like for example calcium, 40-20, for example, and then the other one is like fluorine, which is like 18-9, which is much smaller, isn't it? Then when they exchange ions this way, when they exchange electron this way, the calcium 2 plus won't be much. The won't be like smaller, of course not. I'm just trying to visualize. I mean, make it that way, so you understand more. Anyway, let's continue.
Which one of three ionic compound formed between the metal and the non-metal? That's true.
Submit.
It's
Do you speak
correct.
French? Do you speak
Metal are
French?
really.
I mean,
Wait,
when you
wait.
go to France, go to Canada, I think if you go to Toronto area or Quebec, you have to learn French. But are you going there?
Yeah,
Oh, so you have
somewhere.
to learn it. I see. Oh yeah. I mean, I like learning languages, but French is weird, so weird.
Metal are willing to give up electron and become oxygen, and
Cations and non-metals. I need to.
non-metal are willing to accept electron and become neons. Two chloride atoms are bonded with one magnesium atom. This magnesium has 2 electrons in its valence shell. Chlorine has 7. One chlorine atom can only accept 1 electron. Since magnesium has 2 electrons, it will bond with 2 chlorine atoms. So, chlorine ion are
Cation?
cation,
No.
cation.
What's your answer for this?
I think it is true. No, it's false. Chlorine atoms accept electrons and therefore become negatively charged and become anions. So, so it's like point. Get it now. So it's like video. Chemical formulas. Now that we look at the basic of ionic compound, you have gained visual understanding of how they are created. Let's learn how to represent the formation using formulas. We will analyze the ionic compound magnesium chloride again. This compound is made of magnesium atom and 2 chlorine atoms. Its chemical formula is MgCl2. In all chemical formulas, the metal comes first and the non-metal second. A subscript number is used to indicate the number of atoms in the compound. The formula for magnesium chloride show that 1 magnesium ion combined with 2 chloride ions. Notice that the number 1 is not used in chemical formulas. It is assumed to be the air if no other number is present. No. The following table shows the chemical formula for some common ionic compound, as well as how to read the number of atoms each one contains. Formula: sodium,
Just got myself an iPad, a new iPad Air 3, 2019. So basically, I swapped. I came to the shop and then swapped it. Just have to pay a bit more money and then have a bigger iPad, so I can use Apple Pen on it. So probably on more lessons, I'll be able to show you like the equations and everything clearer. You know.
yeah,
And I can probably use it to draw images, things, Are you still there?
yeah, I'm still here.
Okay, please continue.
Covalent bonds. Another type of compound is made of covalent bonds.
Covalent bonds.
Covalent bonds.
When
A
atoms
covalent
share
bond.
electron. So covalent, I mean like sharing. Sometimes they share equally, and sometimes they don't share equally. Like for example, 4-6 instead of like 5-5, or sometimes
Yeah,
3-7, or sometimes 2-8. So it's still a sharing, but it's sometimes it's not equal, but sometimes it's equal too. Ionic bond is like give and take. So one get everything, one give everything. It's not sharing. Ionic is not sharing. It just give and take. But covalent bond is like sharing.
yeah.
Okay, now I'll take a break now. Alright, so covalent bonds, yes, let's do more of it, shall we? You read, please. You read. Just read it.
Okay. Covalent bond.
Mm-hmm.
Another type of compound
Mm-hmm.
is made of covalent bond. A covalent bond occurs when atoms share electron during a chemical reaction. The result is a very strong bond and a very stable compound. Most chemicals you are familiar with have covalent bond,
Mm-hmm.
including as illustrated in the example water, H2O. In water, one oxygen atom joins with the two hydrogen atom. The water molecules has two OH bond.
Mhm.
We will explore other examples on the following material. Most chemicals found in food, clothing, plastic, drugs, fossil fuel, and even your body are covalent compounds. Covalent compounds are also called molecules compound. Okay, hold on. Covalent bond occurs most often between nonmetals, using the interactive periodic table. Look at the valence electron for the elements in group 14 to 17. So 14. Do nonmetals generally want to give up or gain electron? If you think most want to gain electron in their outer
Okay, just
shell,
look at
you're
the
correct.
periodic table. You can guess if they want to give up or gain electrons. Remember, the rules is to try to get to 2 or 8 electrons. Okay, let's look at non-metals now. For example, chlorine, Cl.
Yeah.
Yeah, Cl over there. Okay, let's look at chlorine. Do you think it want to gain or accept electrons? Let's say it's in
Uh,
group 7, isn't it?
yeah.
So what do you think? Would want to gain or accept electrons?
Um, gain.
Of course, it want to gain 1 to become 8, isn't it? So
Yeah.
chlorine want to gain 1, it will become an anion after it has gained 1. So how about calcium, Ca 20, 4020?
20.
What group does it belong to? Which group does it belong to?
Um, group 20.
No, it's actually group 2 because
Oh, two.
remember the group, right? The first
Oh, yeah.
column is group 1, the second column is group 2. So calcium belongs to group 2. So it has 2 electrons in its outermost shell. So do you think it want to give or want to gain more electrons?
Um,
Is it easier to gain 6 more to become 8? Or is it easier to lose 2 to become 0? Or it becomes
lose.
8 again but smaller?
It would lose.
Of course. So calcium will become a cation. There you go. That's the logic. Okay, let's try again with other one. Let's say phosphorus or nitrogen. Let's say nitrogen. Which group does it belongs to then?
It belongs to.
15A or 5A, isn't it?
Yeah,
Okay, let's say group 5. 5A,
5.
F5. So it has 5 electrons on its outermost shell. So is it easier to gain 3 or to lose 5?
Gain, because 7, so one more should make it.
No, 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 no. Look at the name of the group. It's group 5A, isn't it?
Oh,
It's group 5A, which means there are 5 electrons in the outermost shell of nitrogen, isn't it?
yeah.
So that's why I asked you, is it easier to gain 3 or is it easier to lose is it easier to gain 3 more electrons or to lose 5 electrons?
Um,
Of course, gaining 3 is easier than losing 5, right?
yeah.
So that's why nitrogen, it has a tendency to become nitrogen anion, so N3 minus. So the same logic applies. Let's try oxygen. Let's try oxygen. Okay, you do it. Let's try oxygen. Which group does it belongs to?
6A.
So is it
So
easier to gain 2 or lose 6?
gain 2
Of course.
because
So it will become O2 minus ion.
O2
When
minus.
it gain 2 electron, it will become O2 minus ion.
Oh. Example method. Let's look at a more complex example. The diagrams show the simple covalent compound methane CH4, which makes up the natural gas that heat most home. Each X represent gas that heat most home and represent an electron that originally came from the carbon atom, while the dot represent an electron that came from the hydrogen atom.
Mm-hmm.
Methane, one carbon atom is conveniently bonded to four hydrogen atoms.
Mm-hmm.
The carbon atom has four valence electrons. Each of the surrounding hydrogen atom has one
1.
valence electron.
So hydrogen will become 2. So 2 is like stable. And for the carbon, actually it's become 8 now. So it's stable too, right?
Yeah.
So it's a win-win situation for both to form the CH4. It's a win-win situation.
Yeah. The carbon atom has four valence electrons. Each of the surrounding hydrogen atom has one valence electron. To have a full valence shell, the carbon needs a total of 8 valence electrons, so it needs 4 more. Hydrogen needs only 2 valence electrons to have a full valence shell, so each need only 1 more. Carbon and hydrogen are both non-metal, and they both want to hold on to their own electron. The only way for them to get a full valence shell is by sharing them.
Mm-hmm.
Carbon dioxide, CO2
An example of a covalent compound.
is an example. Using
Okay,
a
let's study this
formula.
one well. Let's study this one well because it's a bit more complicated.
Okay.
Okay, so oxygen start with 6, right? Because group 6.
Yeah.
Carbon group 4. That's 6A, yeah. And carbon is group 4. No, that's CA. Carbon is C.
Oh, carbon. C.
There you go, 4A. So carbon has 4 electrons to start with. Oxygen has 6 electrons to start with. And now you have CO2. So basically, the carbon should be the one in the middle, isn't it?
Yeah.
Okay, so
Each X represents a shared electron that originally came from
came
the
from the
carbon atom.
carbon atom.
while each one represents an electron that came from an oxygen atom. How many electrons is the carbon atom sharing with each oxygen atoms? Each oxygen atom. No. It's two.
They of course 2 electrons. So let's say the number of electrons carbon share with oxygen atom is 2 electrons. You have to say that the number of electrons.
The
The number of electrons that the carbon share with the oxygen atom is 2 electrons. I mean, in terms of logic, it makes sense that way. The number of electrons. Because the electron is 2 electrons, it's like... The electron is 2 electrons, it's like, what? So it's just the number that the carbon share with something. Please fix that. The number that. The number.
Carbon atom is yeah. Carbon atom in the center is sharing a total group 2 with each of 2 oxygen atom. Carbon is in group 14. The oxygen is in group 16. They both have a similar lack of electron in their outer valence shell, so when they come together, they share them.
Okay, you haven't actually shared sound, so that's why I couldn't hear. Okay, let's start again, and then you share the sound.
Okay.
Let's start again, and you share the sound. Okay.
Okay.
There must be that button somehow.
Okay, let's look at the example of CO2 or carbon dioxide and covalent
Okay, I hear it
bonds.
now. Perfect.
On the periodic table, we see that the element number for carbon is 6. So we know that there are 6 electrons. For oxygen, we know that the element number is 8. So let's start by drawing the Bohr-Rutherford diagrams, the full diagrams of all the electrons for these two. So if I have carbon, I have 2 electrons in the inner shell, and then I still have to go all the way up to 6. So 2, 3, 4, 5, 6. Okay, so if I had to draw the Lewis dot diagram, or just the outer shell of carbon, I have carbon, and then I have just those 4 electrons on the outer shell. Okay, so let's just draw 2 over here and 2 over here. I could draw it in a different order if I wanted to, but we'll do it like that for now. You'll see why I kind of chose to do it that way. And then let's do oxygen. And oxygen has 8, so 1, 2. And then let's go 3, 4, 5, 6, 7, 8. Okay. So if I draw the Lewis dot diagram, I've got oxygen, and it just has 1, 2, 3, 4, 5, 6 in that outer shell. Okay, so let's do 1, 2, 3, 4, 5, 6, like that. Okay, so we know that in carbon dioxide, we have 2 oxygen molecules joining with 1 carbon. So let's start by drawing that carbon here and those 2 electrons on either side of it. So 4 electrons in its outer shell. And now let's do the oxygen, and we'll do 1 oxygen over here. 1, 2, 3, 4, 5, 6. Okay, so it has 6 before it bonds in its outer shell. And we'll do that on either side because there's 2 oxygen. And then what happens is the oxygen and the carbon, they share those 2 electrons.
Mm-hmm.
And then they share those 2 electrons.
So it's called double bond. That's a double bond now.
And they share those 2 electrons. Essentially what they do is they have a double bond where they're sharing 2 sets of electrons over here and 2 sets of electrons over here. And you could draw that if you wanted to as C with 2 bonds and an O, 2 bonds and an O, like that way. And then if you counted the electrons then, if they're sharing those electrons, then carbon has the 1, 2, 3, 4 black electrons that it had before, but then it also has the 2 from oxygen over here, so 4, 5, 6, and then the 2 from over here, 7, 8. So it has a full 8 electrons in that outer shell now that it's sharing. Let's take a look at oxygen. It has the 2 blue it had to start, 3, 4, 5, 6, and the 2 black ones over there from carbon, 7, 8. So it has 8 in its outer shell, and it feels pretty stable too now. Now let's take a look over here. Here's our oxygen. It had 1, 2, 3, 4, 5, 6. Add the 2 that it's now sharing with carbon, 7, 8, and it has a full 8 in its outer shell. So the creation of this covalent bond, or covalent bonds, makes all of these individual atoms have stable outer shells.
So it's a win-win situation for all of them. But the trick here is to find out how you're gonna write it, you know. So I have already, my episode 3, 4, I think I have an episode teaching people how to do this. Have you seen it? Your microphone again, it's off.
Yeah, I've seen a bit.
Okay, so basically you should redo the exercises that I made on some of my episode. And I'm sure I have made a video showing people how to do this one.
Yeah.
I mean the dot structure things. Okay, let's continue now.
No, another video.
Okay, we're going to look at seeing.
We build a molecule interactive object to complete this table that we have in the activity. And we'll do the first one together, and then you can do the last 4 on your own. And you'll see that these are all here in collection 1. So right off the bat, I'm going to notice that water is my first one. And the first thing I have to do is just figure out what the formula is. You may already know the formula of water as H2O. And you can see right here, it is right here. So I'm just going to add that into the formula. You could always Google this if you didn't know, or if you missed it over there on the side. There are multiple ways of finding out the formula of something. Okay, so there's H2O. And now I need to find out which atoms are in the molecule. So let's start by building it. Okay, so I'm going to I've got a couple different kits at the bottom that you can play with. Okay, so if I look at the different kits, if I look at kit 1, H2, so 2 hydrogens and 1 oxygen, I can use kit 1 right here. So I'm going to start with my oxygen, and then let's see. Okay, so 1 hydrogen is bonding to it there. You can see if I need to break that bond, I can click it there and they're separate again, or I can bring it back together. And then I'm going to bring it in. And so then it wants me to drag my molecule over here. But first I'm going to take a look at there. So that breaks it all apart again. So if I attached these two, you can see that it's telling me that this is actually hydrogen. And it's not connected to the oxygen at all. So I'm going to cut those apart and rebuild it back up so that the hydrogens were connected to. There we go. So now I have that water molecule. Let's take a look at it 3D. And sometimes it takes a second to load. So this is what's called a space-filling model. You'll notice that the two hydrogen and the oxygen are just kind of attached, and it shows the circular area or the spherical area that all of their orbits are occupying and how they're sharing some of those orbits this way. So it's called a space-filling model.
They're just
Often
filling in
what
the
you see is what's called a
space.
ball and stick model.
This one is
And what
easier to see because you see the bonding between them, right? But when you see the ball filling, the space filling models, you don't see the bond much. Because it's just balls, you know. Okay, let's continue.
Yeah. Comparing properties of ionic and covalent molecules. You are almost done with this learning activity. First, let's compare property of both type of bond. Now you will have the opportunity to apply what you just learned. Okay, go to the washroom real quick.
Sure. Take a break first. Okay, let's go back to it. Comparing properties of ionics and covalent molecules. Let me get a drink.
Ionic molecules. Ionic bonds give ionic compounds particle qualities. Solid at room temperature, brittle, high melting point, high boiling point. Covalent bond. Holding covalent molecules together give them particular properties. Solid, liquid, or gas at room temperature. Flexible, low melting point, low boiling point. Compound. Naming ionic compound. To eliminate confusion, chemists have developed their own
naming system to identify chemical compounds.
Each chemical name refers to only one substance. The names are assigned according to a set of rules. Let's take a look at how names were developed. For ionic compound, naming covalent compound is slightly more difficult and will not be explored in this lesson. Ionic compounds are made of a metal, cation, bonding to a non-metal, anion. The general rule for naming ionic compound made of two elements is as follows. Name of ionic compound equal name of metal plus root name of non-metal plus ideal. Let's take a look at the root name for some common non-metal found in ionic compound. Nitrogen, nitrogen, ox, fluorine, fluorine, fluor, phosphorus, sulfur, sul, chlorine, chlorine, sorry, fluor.
Near. Explore more naming ionic compounds. Let's use this rule to name the ionic compounds MgF2.
MgF2, magnesium, fluoride, The name of the first element is magnesium, and the name of the second element is fluorine. The root name of fluorine is just the first part, fluor. To this, we would add IDE at the end. Recalling formula. Naming of ionic compound, name of
Metals plus root
core
name
name, metal,
plus
plus
ions.
root name of non-metal, plus IDE. Magnesium fluoride. When naming ionic compound, we do not need to take into account that there are two fluorine atoms, F2, in the molecule. Self-check. Using this method to determine the chemical name for the ionic compound.
Okay, you do it.
Ionic compound Be3N2. So Be is Be is beryllium, beryllium, and
Beryllium what?
nitrogen.
No,
Where?
it's beryllium nitride.
Oh, nitride.
It's beryllium nitride.
Beryllium nitride.
You should check the name. It's not berry. It's not berry with double R. Beryllium nitride.
Beryllium.
Like this. Check the chat. Beryllium nitride.
Beryllium nitride. I've seen the name of chemical compounds built using the chemical formula. Now let's see how the chemical name can be used to come up with the formula. What would the chemical formula for the molecule called sodium chloride be? You know it contains the element sodium, Na, and fluorine. Since one is a metal and one is a non-metal, you know this is an ionic compound.
Ionic
You would,
compound. Not iconic. It's ionic.
oh, sorry. Ionic compound.
Mm-hmm.
You would then look at the valence electron of sodium and fluorine to determine that sodium's one valence electron can be combined with fluorine's 7 valence electron. To complete the outer shell, we only need one fluorine for each sodium.
Mm-hmm.
The chemical formula would be NaF. Using this method, determine the chemical formula for
Calcium
calcium
iodide. You do it.
iodide.
Calcium iodide. First, see where they belongs to, which groups.
First is the Ca,
And iodine, where is it?
Iodide is
Which
group
Oh
7A.
yeah, so I, it is a big capital letter I.
I.
Alright, so how many electrons do they want to give and take?
It doesn't say. It doesn't say. Oh wait. Using this. So the formula is calcium 2Y. Oh.
Exactly, because calcium wants to give up 2 electrons, but one iodine want to gain only one, right? So you have to have
Yeah,
two, so you must have 2 iodine. So calcium CaI2. But remember, the number 2 has to be down there, subscript. So
Yeah.
CaI2, okay, very good. Let's
Oh.
continue. Oh, come on, it's not that hard.
No, I'm just tired.
Why? What's happened? What did you do?
I don't know.
It's Christmas Eve. I mean,
Christmas
maybe
Eve.
it's because of the weather. Maybe.
Practice compound. Copy the table below into your notebook and fill in the blank. The first two are done for you. H2O, the name of compound. Okay, so H2O.
You determine it then.
So NH3 ammonia is
As always, so many advertisement.
yeah.
It's like they're trying to sell things, but they don't understand that people are so poor now after COVID. Oh dear.
Ugh.
Don't feel so tired. Just drink something, tea
Yeah,
or coffee or something like that. Are you okay with tea or coffee?
I don't think it's the age yet.
What do you say?
I think I drank teas once before.
Okay, how about milk tea?
Milk tea, a bit.
Of course, it's a favorite among teenagers. Milkshakes and milk tea, you know.
Okay.
How you get it? Okay, so NH3.
Okay. Anomian, so nitroxide and hydrogen.
Mm-hmm. Nitrogen is
Hydrogen is free, so
one nitrogen, three hydrogens. Number of atoms, total atoms like 4, isn't it?
yeah, so
Covalent or ionic?
nitrogen's like 5.
Group 5, and hydrogen is group 1. But hydrogen, it's not a metal, isn't it? It's an exception to the rule. Even in group 1, but hydrogen is not a metal.
Okay,
So basically, what is it then? NH3? What kind of covalent or ionic? It's not ionic. because this is not a metal and non-metal combination, isn't it? So it can only be covalent, isn't it?
Yeah.
There you go. That's your answer. Covalent.
Covenant.
Covalent.
Right one.
Okay, now CO2, carbon dioxide. Don't worry, I'm a very patient person. You can be slow, but I want you to be to have a confidence when you do it. So it takes many more hours. I'm okay. Oh, and you turned off your microphone already. How could I hear you?
Sorry.
Oh, okay. Now, so carbon dioxide is
Dioxide. So
dive into, So carbon dioxide means, what's the chemical formula?
so carbon dioxide.
Yeah.
Wait, hold on. C CO2. So CO2.
CO2. So one C and two oxygen, isn't it? So totally
Yeah.
three atoms. Is it covalent or ionic?
It's it's I think it's ionic, right?
Mm-hmm.
Yeah, ionic. Oxygen, oxygen, two oxygen. Oxygen. So it's ionic. NaCl. NaCl is sodium and chloride. So it's
Sodium chloride, right? So one
yeah,
sodium, one chloride.
yeah.
So
So
two atoms, covalent or ionic.
yeah, it's ionic.
Of course, because it's a metal and non-metal combination. Let's continue. There you go. Good, good. Okay.
Okay.
Oh, there's a video example.
Yeah.
No, I don't think you need it, right? You don't. Okay, because we did everything, I'm sure. You can watch it later, but I'm sure we did everything. Now let's continue. Is that
That's
the end?
everything.
Oh, that's the end? Okay, then
Yeah.
watch this one then.
Okay.
Okay, let's take a look at these practice questions and filling out this table. So in this table, for most of them, we've been given the chemical formula down this column. We didn't get given the formula for carbon dioxide, but we trust that you can figure that formula out on your own. If you need to do some research, by all means do that and look through other parts of the course and the lessons that you've already looked at. And then we have to find the name, and for many of these, this has also been given. And then we have three columns really that we're looking at here, and that's the elements in a compound, the number of atoms in a compound, and whether or not it's going to form a covalent or an ionic bond. So let's start with the first one. We'll do the first two here together, and then you can do the other four on your own. Okay, so let's start with the name. We've seen this one before, H2O, and we've used it in previous examples. So let's start by naming this, and we know that this one's water. Okay, so now we need to look and see what elements are in this compound. And we know that there's two H's, H2, and that there's one O. So if you don't know the name of those elements, you can use the periodic table and you can go and take a look at the name of them this way. So we know that H is hydrogen. So I'm going to go back and put in that there are two H's or hydrogen and that there is one O or oxygen. Okay, so there are those elements. And then the total number of atoms in this compound in total, well, the two hydrogen plus the one oxygen is 3. Okay, so now we have to figure out whether or not this is a covalent or an ionic bond that forms between the hydrogens and the oxygens. So for this, we're going to look and we're going to go to the periodic table of elements that you have access to. And you can play with the classifications and you can have it show you which elements are metals and which elements are nonmetals. And let's start by looking at it from the metals. Okay, so we're looking for H and O. So right now this is highlighting in blue all of the metals, and our hydrogen and our oxygen are both gray. So they are nonmetals. Let's double check that. Okay, so now all of our nonmetals are highlighted in green and they are both highlighted. So we have two nonmetals bonding together. And when we have two nonmetals bonding together, we have a covalent bond. And we know this because we have two nonmetals bonding together. Okay, so there's our first example. Let's take a look at our second example. Here we have AgI, and the name of this compound is silver iodide. And so let's go take a look and see what Ag and I are. And we have our Ag right here. Oops. Okay, so our Ag, and that is silver, and our I, which is iodine, So let's go and write that in. Okay, so we have 1 Ag, which is silver. We have 1 I, which is iodine. Okay, and now in total, because we have 1 of each, we have 2. And now it's time to figure out whether or not this is a covalent or an ionic bond. So let's go take a look and see if Ag and I are metals or non-metals. So let's have it highlight all the metals. And here our Ag is highlighted, so we know that silver is a metal, which makes sense.
Makes sense,
I think
of course, makes
most
sense.
of us probably could have guessed that one. And then we'll take a look at our non-metals. And here is our iodine. So we have a metal and a non-metal bonding in this case. So when we have a metal and a non-metal, we have an ionic bond. Bonding together. So a metal and a non-metal create an ionic bond. And if you think back to what we studied in our ionic bonds, in ionic bonds what happens is that usually one of the two ions is actually giving away an electron, and that electron's being taken in by another molecule, so you end up with positively and negatively charged ions which are attracted to each other. And that's that ionic bond, where there's the ions, or those charged particles, bonding together. In our covalent bond, when we have the two nonmetals bonding together, they're sharing electrons. Instead of giving them up, they're sharing them, and they orbit around both of the atoms to create that bond. So we've done the first 2 together. You can do the last 4.
You got it, man.
Yeah, that's it.
All right, now, so I think there's nothing more, right? Okay, so what's the next one? What's the next topic? 2.6 something.
2.6, analyzing the impact of using compound.
Okay, then you go there. Then we can still do that.
Ooh.
Hoorah!
Okay. Cost benefit analysis. When scientists assess the benefit of
Wait, assess. This is assess. Testing
Assess.
and analyzing, assessed. It's not
assess,
access and assess, it's two
I said
different words.
assess.
So this is assess.
Assess the benefit of compound. They must also assess the cost. Take oil, for example. It consists primarily of hydrogen and carbon atoms. It is one of the main sources of energy in the world, and it's also used to make other products, such as plastic. As a society, we depend heavily on oil, but we need to take into consideration its environment impact. Extracting oil from the ground causes environmental damage, and burning it produces greenhouse gas.
That leads to
That
global
leads
warming. But still, it's the most efficient kind of energy source, you know. Even though we burn it, it's still efficient. We have to use it. That's the thing. It's not that easy. It's not easy to change to use other kind of alternative sources because they are not as efficient as fossil fuel. That's why we still need them. That's the thing. Even after like 60 years or 70 years, after knowing the harm they can cause,
Okay. Ah, in this learning activity, you will consider two different case studies of the economic, environmental, social impact of the use chemical compound. You would then use the cost-benefit analysis method in your assessment of that chemical compound, which is found aboard of many Canadian households. Case study. Case 1.
Case 1 DDT,
DDT.
case 2 oil.
Dichro-
Dichloral, diphenyl, trichloroethane. Wow, such a name!
Water name. It's big.
What a name, oh my god. Insecticides, it kills off insects, of course. The substances that contain chloral, or something like chlor, are most likely toxic, you know.
Yeah.
Initially dying from disease such as malaria. You know what malaria is, right? You know what dengue fever is? Dengue fever.
What is that?
Basically, dengue fever, it's when basically people get bitten by mosquitoes and they start to have like fever up and down, up and down, up and down all the time for like almost like 2 weeks or something like that. 1 or 2 weeks.
Oof.
It's not fancy, of course. That's dengue fever. For malaria, it's similar because you also get bitten by mosquito, but then you start to shiver, to shake, and of course it causes you to get weaker and weaker too. Malaria, and your face will turn like yellow, a bit yellow.
Oh.
I mean, these diseases are still prevalent in Africa and some part of Asia too, if you're not careful, because there's just so many mosquitoes. So when you see mosquito, kill them.
That's so small. Yeah. DDT or dish local trilocane is synthetically manufactured. Insectable. Initially, it prevent people from dying from disease such as malaria. However, as time went on, negative effect started to arise. Cost-benefit analysis. Have you ever created a pros and cons list to help you make a decision?
Mm-hmm.
This is
This is
exactly
exactly what a cost-benefit analysis is.
cost-benefit analysis. Analysis is this analysis which focus in which focus exclusively on the
Wait,
spraying
today's
of
Friday, right?
Huh?
Is today Friday?
Yes, they
Oh yeah, today's Friday. So you're done with math, am I right?
Yeah.
So when you have to go back to math again, because we've been doing science for like 3 days non-stop. Was it 3 or
Maybe
4 days non-stop?
maybe we could go it on Monday.
We started the science on Monday, right? So it's 4 day continuously.
Wait, no, I think it's math on Monday.
Alright, so let's do my math on Monday, and then Tuesday, Thursday and Friday next week we do science then.
Okay.
Okay, so I think it's time now. Let's just stop the video here. Okay, that's the end of my videos. Please like, share this video with your friends, subscribe to my YouTube channel, and press on the bell button next to the subscribe button so you can get notified about my new uploads, okay? You can also press follow my Facebook, but please don't add me on Facebook as friends, okay? Cảm ơn các bạn đã theo dõi nha. Các bạn hãy nhấn vào like, chia sẻ video này bạn bè các bạn. Nhấn vào nút đăng ký kênh YouTube mình và nút cái chuông kế bên cạnh để đăng ký kênh á, để mà các bạn sẽ được thông báo về những video mới nha. Các bạn cũng có thể nhấn vào nút theo dõi Facebook mình, nhưng nhớ đừng kết bạn Facebook mình nha. Thank you and see you. Bye.